All right, here we go. Let's say you are the Coast Guard. You're in this white boat. Both these black boats need help. They're stuck. Let's assume that you can't see them. There's a fog or something. Okay, but you have to do radio communication. You got to be able to talk back and forth using sonar and radar, blah, 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 blah. How would the Coast Guard captain give directions to get the white boat to the ships? Why would an ordered pair like XY not be effective? So let's start off with the first place. How would you give directions?
My brain thought of it as we use directions like northeast, southwest, and like degrees.
Okay, good. I totally agree with that. You would say something like you are going some degrees in a direction. Okay, so a little bit strange, but you could say like go 200 and let's say that's 200 degrees, and that would be southwest. Okay, 200 degrees southwest would be the angle that boat needs to travel to get to the black boat. Everybody agree with me on that? What else would you need to give? What other information would you need to give to get to that boat? Aaron? The distance, right? You need to go 200 degrees and you need to travel 8 kilometers, right? Those two bits of information would be pretty helpful to get to there, okay? To get to this boat, it looks like you got to go like 260 degrees and 7 kilometers, right?
Yeah.
That's a lot better than X comma Y here, right? X comma Y would be like travel left for 3 kilometers and then travel 6 kilometers south. That would become really strange, and it just doesn't work quite as well. Yes, sir? Gotcha. Okay, so that idea is what we're going to go into today. Okay, instead of living in this world of X, Y, we're going to live in a world of angles and distance. Okay, for example, let's say I've got this right here graphed. Okay, let's see this little red guy right here. Okay, if I want to get, oops, that's not what I wanted. Turn that off. This little red dot. We could say I went over this much and up that much. But instead, we could talk about it on a polar graph. And on a polar graph, we are traveling pi over 6 or 30 degrees. And we go 6 rings from the center, 6 kilometers out. It's going to tell me the same information as an XY, but in a new matter. Okay, in a new frame of thinking. Okay. Eventually, we're going to get to this. And we're going to be able to graph pretty pictures. We can do that in our calculator. You can do that on Desmos. We can do some of it by hand. We're going to do basics by hand, but eventually that's where we're headed. Let's go. Today, we are going to graph some polar coordinates. Again, we're working with angles and distances. So before, we've always graphed stuff with X, comma, Y. Today, we're going to graph stuff with R, comma, theta. R is going to be your radius. Theta is going to be your angle. Okay, we're going to do a couple. We'll fill in this as we go. Let's start with the first one. Okay, for letter A, we're graphing 1 pi. So the 1 is the radius. So as you look at this thing, it's like the first ring. It's like 1 inch or millimeter, whatever you want to call it, from the center. Okay, and then pi is my angle. So right there is A. You can go ahead and label it with a dot. That is what A is representing. Letter B says -5, 3 pi over 2. So -5, 3 pi over 2, if I want to graph this guy. Well, here's where 5, 3 pi over 2 would be. It would be right here. We go from the center, we go 3 pi over 2, and we travel 5. That's not where my dot is going to go. If I'm doing -3 pi over 2, any thoughts on what that is going to represent here? Where do you think that -5 is going to tell me to do? 5 tells you to walk down, or to walk out 5 this way. So if it's -5, what do you think I'm going to do instead? It's like backing up, right? I'm going in the same path, but instead of going this direction, I'm going to go the opposite direction. So that right there is -5, 3 pi over 2. So here's what we state. If R is negative, I like to say the phrase, you ride the line. Okay, obviously that is just a cool little phrase that I made up, trademarked, but it's riding the line. So we started off being down here, but if we don't want it there, we have a negative radius. We ride the line. It starts with the R. We ride that line across to the other side, and it's going to give me the same value. Everybody good there?
Yeah.
Next one says 2, comma 7 pi over 3. So 2 is easy. It's the second ring. But 7 pi over 3, that's not on my unit circle. What, or not on my graph either. What am I doing if it's 7 pi over 3? What could I do to find that angle? I'm going around more than once. It's like 2 pi plus a third. So it's like just doing 2 comma 1/3 right there. That is C. So nothing fancy there. If the angle's too big, just like we've always done, simplify. Letter D, -3, 2 pi over 3. Try that with your neighbor real quick. Show me with your fingers which quadrant did you end up in. If you did -3, 2 pi over 3, show me with your fingers which quadrant. Lots of 4s. I agree with you on that. Again, -3, 2 pi over 3, that's right here. -3, 2 pi over 3 would be right here. But I've got a negative radius, and a negative radius tells me to do what? Ride the line, ride it across. So instead of down here, now I'm over here, right there. You're staying on that same straight line. The other thing, sometimes as you ride the line, you're like, which one of these lines is it? If you started with a 3 on bottom, it's going to end with a 3 on bottom as well. Just pay attention to that. That way it's easier for your brain not to play tricks on you. Letter E, 4 negative 11 pi over 6. So obviously I'm on the fourth ring, but a negative 11 pi over 6, here would be 4 positive 11 pi over 6, but it's not going here. What do I do with a negative angle? Go the other way. So 11 pi over 6 is like going this way around. If I go negative 11 pi over 6, it's like going the opposite way around. What angle is the same thing as negative 11 pi over 6? Pi over 6. This is where letter E is going to go. How is this new dot related to 4 positive 11 pi over 6? It's flipped over the what axis? The x-axis. You can just flip it over the x-axis. If you have a negative angle, it's just like taking that angle and flipping it over the x-axis. It would match up that direction. Okay, so let's try one more. The last one here, -2, negative pi over 4. So let's go to 2 pi over 4 first. 2 pi over 4 would be right here. But that's not where my angle goes. I have a negative radius. What am I going to do with that angle if I have or with that dot if I have a negative radius? Ride the line. It would take me over to here. But that's not where that dot's going to go because I have a negative angle. What am I going to do if I have a negative angle? Flip over the x-axis. That right there is where F ends up. We just did both things. If both are negative, do both. Do both. We rode the line and then we flipped over the x-axis. Or what else could you say we did if I did both? How does this dot compare to that original dot? We flipped over the y-axis. You got to remember that. I'm perfectly fine with you saying you flip over the y-axis, but you got to remember why that happens because you're riding the line and then flipping over the x-axis together. Everybody decently okay so far? The next set here, okay, I want you to try these 6. Now, obviously, they're in the degrees, and yours is in radians, but you're smart enough to figure that out. Talk with your neighbor and graph those 6 points. Go. Here we go. Letter G is 4, 30. You don't really need me to do a whole lot for that. 4, 30, that's here. 4, 30 degrees, pi over 6. Oh, hey, guess what? E and G are the same point. Great. Okay. 5, 150. That one's pretty straightforward. We go to the fifth ring, 150 degrees. That's right here. We can call that H. I is -2, 210. Show me with your fingers. Which quadrant did you end up in for -2, 210? Which quadrant did you end up in? Should be 1, because here's 2. 210 would be right here. But I have a negative radius, so if I have a negative radius, what do? Ride the line, ride it straight across to the other side. Boom, there's my new dot. There's I. Letter J, 3, comma, negative 60. Show me with your fingers which quadrant is 3, negative 60 going to fall into. 3, negative 60 should fall into the fourth quadrant because 3, negative 60 would start right here. But I've got a negative angle, and if you have a negative angle, you flip over the x-axis. Hey, guess what? D and J are the same point. Negative 5, negative 225. Show me with your fingers. Which quadrant is negative 5, negative 225 going to end up in? Fourth quadrant, because here's 5, 225 right here. A negative angle or a negative radius is going to ride the line across. A negative angle is going to flip me over the x-axis. That spot right there is K. Or you could just say if I started here, flip over the y-axis. I'd rather just ride the line and then flip again, but it's up to you. And then L 2, 450, that's too big. Subtract out 360. It is 2, 90. It is right here. Questions on how we graph those points? Pretty straightforward. Now let's do this. These are just a certain type of question. I really like them. That's why we're going over them in notes, but I think it helps you to better understand what's going on. Which of these is not the same point? So they're giving you 4 ordered pairs. 3 out of the 4 are going to describe the exact same ordered pair. Even though none of them look the same, they're describing the same ordered pair because you can write things differently but get the same point. For example, negative 4, 225. Okay, 225 would be here. 4 would be here, but it's negative. So what is that negative 4 going to do? Write a line across. Boom, right there. That is where A belongs. Once I've found A, then I could do B. B is 4, 405. 405 is too big. We subtract out 360, so it's really 4, 45. Hey, guess what? It's the same thing as A, so that's a good sign. If A and B are the same, then we're good. It's got to be C or D because 3 of them are going to be in the same spot. So then we go from there. Then we're graphing negative 4, 45. Which quadrant is negative 4, 45 going to end up in?
3.
Yeah, that's 3 because it's negative 4, 45. We started here, but instead we rode that line across. That's where C is going to be. So C is the incorrect answer. We know that already, but D better match up there, otherwise I screwed it up. I always like to check them all because otherwise you might make a mistake at the end. Letter D, negative 4, negative 135. Here is positive 4, 135. I've got a negative radius, so I can ride that line across, and then a negative angle, flip it up. A, B, D are all on the same point. It is letter C that's on the wrong point. Make sense on how that works?
Yeah.
Try the number 2. Try number 2. See if you can do that with your neighbor. Figure out which one doesn't work. Fingers. 1 for A, 2 for B, 3 for C, 4 for D. Which one does not belong? We're saying number 4. Let's see if we're right. 2, negative 30. So here would be 230, but I got a negative angle, so I flip down. There's A. Letter B. Negative 2, 510. I don't like 510. Subtract out 360. What is that? 150. Sorry, math is bad. Negative 152 is here, but I got a negative angle, so I write it across. I put it in the wrong spot. Sorry. That is B as well. Then we do C. Negative 2, 150. So here's 150. Negative 2. Yep, it rides across. C is the same. D is 2, 480. If I subtract out 360, I get 2, 120. Nah, that's not right. That's not what I wanted. D is in the wrong spot. Make sense on how we did that? Let's go down below. So this is probably the most challenging thing of the day. And we struggled with it a little bit last period. See if we can get a little better at it. Excellent. Here we go. I would be too. How else could we rewrite these points? So what's happening here is I gave you an ordered pair, like 5, 2 pi over 3. And then we're going to rewrite it in a different way. Okay, very similar to what we just did up above. But we're going to rewrite this in a different way based off of what they tell me. Okay, so first of all, we're trying to do 5, 2 pi over 3. So 5, 2 pi over 3 would be like this dot right here. You can graph it up above if you want. I'm just putting it right here. Okay. Now what they're asking me to do is say, all right, we're going to rewrite that. We want the radius to be greater than 0, but my angle to be between negative 2 pi and 0. What do you think you want my radius to be if it needs to be greater than 0? If I wanted to match this guy. It's got to be 5. There's no other choice that's going to get me the same distance. It's got to be 5. All right. So I need to have a radius of 5, but I need the angle to be negative. So how could I match up with this dot right here with a radius of 5, but I need the angle to be negative? What would I do if I have a negative angle? Flip over the x-axis. So I would really want it to be this guy. If I had this dot starting and I had a negative angle, that's going to flip me over the x-axis and put me right there. So the point that I want is 5, comma, negative 4 pi over 3. That's what I'm looking for there. The radius is positive, the angle is negative, but they're describing the same point. Let's do letter B. This time I want the radius to be negative. So obviously, what's my radius going to be? Negative 5. But I want the angle to be normal. I want the angle to be between 0 and 2 pi. All right, so we got to look at my graph. I want my radius to be negative 5, but to match up with that guy right there with a positive angle. So what am I going to do if I want the angle to, or the radius to be negative? Evelyn? We're going to ride the line across the other side. Oh, it's like I'm talking about 5 pi over 3. Negative 5, comma 5 pi over 3 is describing the same point because I had a negative radius. It's going to ride that thing straight across. It's a little weird at first. Just double check yourself when you get done. Do they match up? Yeah, they do. We're good. Okay, last one. This time, I want the radius to be greater than 0. So my radius is 5. But I want the angle to be between 2 pi and 4 pi. So I want to get to this spot right here, but I want the angle to be between 2 pi and 4 pi. So what do I need to do with my original angle of 2 pi over 3 to get to be the same ordered pair? Add 2 pi. So if I'm adding 2 pi, it's like I'm adding 6 pi over 3. I'm going not only around, but around again. So it'd be the same thing as 5, comma 8 pi over 3. Kind of makes sense how that works?
Yeah.
It's just describing things in a different way. This next one we struggle with. I'm going to give you just a start here. Negative 3, comma negative 5 over 4. Try and graph that first. Try and figure out where is negative 3, negative pi over 4 going to be. Let's change it to all positive first. That way our brain doesn't melt. So negative 3, negative pi over 4. Here would be 3 pi over 4. It'd go right here. What's the negative radius going to do if I have a negative radius on this dot? Ride the line, so I'm across to here. And then I have negative pi over 4. So what else do I need to do? Flip over the x-axis. So this dot right here is the same as that one. So we could say it's negative 3, negative pi over 4, or it might be easier for you to write it as 3 pi over 4 first. That way everything else doesn't seem quite so crazy. Okay, so this is the dot we're talking about. Work with your neighbor. Try to write those 3 alternate ordered pairs. Go. Here we go. Let's do it. My first one, I want the radius to be greater than 0 and my angle to be negative. So again, I'm trying to match up with this guy right here. Grace, what do you say for your radius? It's got to be 3 because my radius has to match up with 3. So yeah, what about your angle here? Good. Negative 5 pi over 4 because a negative angle is going to flip her over the x-axis. And so she wants to match up with that guy. Negative 5 pi over 4 is what we're looking at. So I took this one, 3, negative angle, flip it over. We're good. Good. There's my first one. Second one. This time I want to be a radius less than 0. So Sam, what do you think my radius is going to be this time? Negative 3. Again, it's 3. It's got to be the negative angle. And then I want the regular angle to be positive. So what angle did that match up with? 7 pi over 4. Because if he had a dot that went right here, but with a negative radius, it would shoot him across to the right spot. So it is at 7 pi over 4. Good. My last one. I want a radius greater than 0 and an angle between 0 and 2 pi. What do you say for that one here, Jack? What do you say for your radius? Radius has to be 3. And then I want my angle to be bigger than 2 pi. So what did you have to do with your angle? Yeah, just add 2 pi. So he's got 3 pi over 4. And then he's adding 2 pi. So it's like adding 8 pi over 4. It gets you 11 pi over 4. That's what I'm looking for. Questions with graphing ordered pairs? We're going to do it quite a bit. You'll get better at it as we go. The first couple times it's a little bit tough. Let's go to the backside. Okay, so this looks strange, but it relies on everything we already know how to do. I'm not teaching you anything new here. It's just understanding what we're doing. Okay, so what we're doing is we're converting from polar to rectangular. Okay, again, I kind of showed you this earlier, but if we had Desmos up, okay, and we graphed this ordered pair, it is the ordered pair 3, 7 pi over 4. Or actually, I lied to you. Let's make it like 2. Oh, no. I hit it. There we go. All right. So if I've got this ordered pair right here, it is 2 and 7 pi over 4. Okay, that's the angle it's on. I want to know what would the XY value be. Okay, if I switch back to this graph, it's like randomly in the middle. It's not nice and neat on an ordered pair. We've got to figure out what is the same. If I wrote something as R and theta, what would it be as X and Y and back and forth? And it seems kind of complex. It's not too bad. Okay, so the first thing we're going to do is we're going to convert from polar to rectangular. Okay, when we say polar, we're talking about R and theta, a radius and an angle. When we talk about rectangular, that is X, Y, the thing we're most comfortable with. Okay, so we're going from polar to rectangular. So let's look at number 1. Convert each coordinate from polar to rectangular. So again, if this is polar, what does this 6 and pi over 6 represent? The radius and the angle. It's R and theta. I need to get X and Y. So here's what that means. I need to somehow use R and theta and get X. Is there any formula that we have talked about in the last 3 months, every single day, that take R and theta and get you X? This guy, right? And it looks kind of strange, but cosine of theta equals X over R. You ever heard me say that before? Yeah, we've done that once or twice. We've got theta, we've got X, we've got R. So we're going to take the two things that we know, which are R and theta, and get X. And the best way to do that is just multiply both sides by R, and it gets me the same formula. Okay, so that's what we're going to do. We're going to figure out what X is by using R cosine theta. That is our formula we're using. It's the X formula. It's going to get me my X. Then all we do is plug in. What's my R? Well, my radius is 6. What's my angle? It's pi over 6. You don't need a calculator for that. You're very capable of doing this in your brain, and you're always going to do it in your brain. 6 times cosine at pi over 6. What is cosine of pi over 6 going to get you? It is radical 3 over 2. Okay, we're going to find the exact value, so we don't want to use our calculator. We reduce. What's 6 divided by 2 going to get me? 3. Radical 3. That is my X value. That is the X value of my ordered pairs. 3 radical 3. That's great. That's just the X value. I need to find my Y value. So I need a formula that somehow relates R and theta to get me Y. Is there any formula you know that would get you R and theta to get you Y? Y equals R sine theta. Yeah. Y equals R sine theta, just like cosine, but it's getting me the Y value. We plug in 6 times sine of pi over 6. What is sine of pi over 6 going to get me? 1/2. So it's 6 times a half. My Y value is 3. And so what does that get me? Well, that gets me my ordered pair. That my ordered pair is 3 square root of 3, 3. They're gonna be a little ugly. You're gonna have radicals in it. It's okay. This is my answer. What we just found out is that this thing right here is exactly the same as that thing right there. They don't look the same, but they are. Yes, ma'am.
When we're solving for like the third variable, do we have to use like the sine formula?
You want to use the sine formula. Yep. So let's show you what that looks like. So what was our original radius? 6 and pi over 6, is that right? So if I set this up, I have 6 and pi over 6. Pi over 6. See that dot right there? Purple and red, they're on the same spot because the other one is 3 radical 3 comma 3. Okay, if I graphed it right now, it's like at 3 radical 3. That's kind of a weird number, but it's 5.196. That's where that is. And if I graphed it with my polar graph, oh yeah, it's at 6 pi over 6. They're the same thing. They look different. They're exactly the same. Kind of makes sense how we convert. You take the two things you know, r and theta, and you get x and you get y by using those two formulas. Okay, work with your neighbor. Try and do the second one. So negative 2 comma 3 pi over 4. Convert it. All we've got to do here is plug into our two formulas. Again, they gave you r and theta. We're going to rectangular form. So rectangular form means in the end, I want to get x and y. So just be able to set it up. So if I plug in, it is negative 2 cosine 3 pi over 4. William, what's cosine of 3 pi over 4 going to get me? Negative square root of 2 over 2. The 2's are going to cancel. The negatives are going to cancel. I get radical 2. That's what his x value is. Okay, then we're going to do the same thing for our y. Our r value is negative 2. Theta is 3 pi over 4. Then we just do it. Negative 2 times, Morgan, what's sine of 3 pi over 4 going to get me? Radical 2 over 2, and it's positive. Good. The two 2's are going to cancel. I got a negative square root of 2, so my y is negative square root of 2. So my answer is square root of 2, comma negative square root of 2. That's it. Again, we could go to Desmos and graph that thing, and it would be perfect. Okay, if I went here to Desmos and I graphed my x value of 2 and my y value of negative square root of 2. I graphed this wrong. Square root of 2. Boom, it gets me a dot right here. Guess where that dot is? It is at 7 pi over 4 and 2. It's the same ordered pair that we started with. Okay, or negative 2 and 3 pi over 4. Same thing. Makes sense so far? Let's go to the next part. Now we're just doing it the other way. Now we're converting each coordinate from rectangular to polar. So this is rectangular. 2, negative 2 is rectangular. So what does this 2 and negative 2 represent? X and y. We're trying to get to polar. So I'm trying to get to r and theta. So we can do them separately. But we need a formula that somehow uses x and y and gets me r. Is there any formula that perhaps we've discussed before that gets you x and y to get you r? Pythagorean Theorem. X squared plus y squared equals r squared. Then we just plug it in. 2 squared plus negative 2 squared equals r squared. So 8 equals r squared. What is your r going to be equal to? 2 root 2. That is my r value. Great. There's that one. I need another formula that somehow gets me x and uses x and y and gets me theta. Is there any formula that somehow puts together x and y to get me theta?
No.
Yes, there is. It's tangent. Tangent of theta is y over x. Okay, so let's set that up. Tangent of theta is y over x. So I'm trying to get theta. So tangent of theta equals y over x. That's the formula I'm using here. That's how I find theta given x and y. So tangent of theta, my y value is negative 2. My x value is a positive 2. Oh, it's negative 1. So we are trying to figure out when is tangent of theta going to be equal to negative 1. Technically, we're doing inverse tangent. And we're asking ourselves the question, when is tangent going to get you negative 1? When is tangent going to get you negative 1? 135 degrees. Or or 315. We could do degrees or radians. You just got to pay attention to what I'm doing. Somebody told me degrees, so I went degrees. 135 degrees. That's in the second quadrant. Or 315. That's in the fourth quadrant. It's not both. It's one or the other. Which angle do you think I want to use here based off of the original ordered pair? 315. Megan, why are we picking 315? Good. This ordered pair is in the fourth quadrant because my x is positive and my y is negative. So Megan picked the angle where her x was going to be positive and y was going to be negative, or in other words, the fourth quadrant. So 2 square root of 2, comma 315 degrees. That is the ordered pair that matches 2, negative 2. Makes sense so far? Do the other one. Go. Here we go. We are given x and y here. We need to get r and theta. So if I want to get r, I'm doing Pythagorean Theorem. So it is negative 1 squared plus negative square root of 3 squared. Make sure when you square stuff, it goes positive. Somebody on their test the other day didn't do that. It's bad. That's 1. That's 3. 1 plus 3 is 4. I square root that. What's my radius going to be? My r is 2. We do the same thing here. Tangent of theta equals y over x. So it's y over x. So tangent of theta needs to get me a positive square root of 3. In which two quadrants is tangent going to get you a positive square root of 3? 1 and 3. So my theta's here. You have two options. Theta could be 60 degrees or 240 degrees. That's when tangent's going to be a positive radical 3. Which one of those two do I want here based off of my information? 240, because the x and the y are both going to be negative. So my answer is 2, 240 degrees. That is going to be the same as this original ordered pair. Questions on something we did today? We'll do the other part to start tomorrow.